Hello everyone, Ismail is here. Today we're going to start the lesson 4.1 with a new chapter, triangle trigonometry. This chapter 4 always is talking about trigonometric function, everything related to the sine, cosine, and all of these trigonometric. Now, what we are going to learn here in this lesson, we're going to know just how we can evaluate trigonometric function for acute angle of right triangles. Then we're going to learn how to solve the triangles, okay? So we're going to learn about the sine, cosine, tangent, cosecant, secant, cotangent, and the reciprocal function, of course. And we are going to learn about the angle of elevation, angle of depression, and inverse of sine, inverse of cosine, inverse of tan. Okay, now let's start now with the first thing with the trigonometric ratio. Now the trigonometric ratio, to understand the trigonometric ratio, is we just summarize it in this small key concept in this triangle. So for example, let's say I have this right angle triangle, and in this right angle triangle, okay, always should be right. If it's not right angle triangle, it's not, we can't use the ratio. Now the first thing, we know that the longest side, okay, so the longest side of the trigonometric is considered as hypotenuse. Or how we can know which side is hypotenuse? We can know that longest side, or we can know opposite to the right angle. Always opposite to the right angle. Which one is the right angle? This one is the right. So which side is opposite? This side here. So of course this one will be my hypotenuse. Now for the adjacent or the opposite. Now the adjacent or the opposite, it's represented by the given theta. So for example, look to this theta. Which side is opposite to this theta? Is this side here, okay? So of course this one considers the opposite, and because this one is the hypotenuse, which is this one here, hypotenuse, so of course the adjacent will be the other one, which is this one here, okay? So now we need to start to identify the ratio. Always first number one, we look to the given angle, okay, given theta. Which one is the given theta? Then number two, we identify the opposite, and okay, we identify the opposite and the adjacent regarding the theta, okay, regarding to the theta. Number three, then we use the ratio of the sine, tangent, or whatever, okay? So first step. Now let's take the same example here given in front of us. So let's say this is theta, okay? So I need to find now the sine. So what is the sine rule? This we have to memorize it. So the sine theta, okay, sine theta, so the sine for this given angle always is opposite over hypotenuse. So it will be opposite, so this side here, over divided by the hypotenuse, which is this side here, okay? Now for the cosine it's saying adjacent over hypotenuse. Adjacent over hypotenuse, which means regarding also the given theta, we look to the adjacent, then we look to the hypotenuse. This is for the cosine. Now for the tangent, so the tangent it's saying opposite over adjacent based on the theta. So opposite is this side from theta, adjacent from the theta side, so this is the opposite. Now how about the cosecant, secant, and cotangent, which is the three things written here? So the first thing, we can say the reciprocal, okay, reciprocal of the sine is cosecant. What's the meaning of reciprocal? Reciprocal mean you flip. For example, let's say 2 over 3. So flip 2 over 3, okay, it will be what? 3 over 2. So this is the same thing of the reciprocal. So when I say that cosecant is the reciprocal for the sine, so it will be 1 over sine theta. So this one is the cosecant. And because I flipped sine, so of course I have to flip between opposite and hypotenuse. So the cosecant will be hypotenuse over the opposite. So we just flip the rule. So the same thing happened with the cosine. Cosine is 1 over, the reciprocal for cosine is 1 over cosine theta. So it's adjacent over hypotenuse. Of course, the secant will be the flipping adjacent over hypotenuse. It will be hypotenuse over the adjacent. Now the last rule, which is the tangent. The tangent is 1 over, okay, let me change the color. So the tangent is 1 over tan theta. And we know that tan theta is opposite over adjacent. Okay, opposite over adjacent. So if I reciprocal, it will be adjacent over the opposite. So this is the cotangent. Okay, so this is the sixth trigonometric function that you need to understand. Now we have also something for the tangent. Now there is another rule for the tangent. We can use it, which is this rule here. Also, you need to memorize this rule. The tangent also can be written as sine theta over cosine theta. So what is the reciprocal will be, which is the cotangent? So we flip the sine over cosine, it will be cosine over sine. So cotangent will be cosine over sine. Now these are the rules we need, or the ratio, we need to memorize them always to understand all the question. Now let's start with the first example. First, let's read the question. The question says, find the exact value of 6 trigonometric function. So I have 6 trigonometric, which means I have to find sine, cosine, tangent, and cosecant, secant, and cotangent. So I have to find these 6. Now how can I find them? As I told you before, start with the given theta. So which one of these from this question is the theta? This side. Now identify the opposite, adjacent, and the hypotenuse. Now based on this angle, the opposite side is this one here, which is the 8. So this one is the opposite. And the 15 will be my adjacent. Why 15 is adjacent, not the 17? Because as I told you from the beginning, the right angle, opposite of the right angle is the hypotenuse. So this one here is the hypotenuse. Okay, now let's start, do whatever. Let's find the 6 ratio. Now the first rule is the sine. The sine, what's the rule of the sine? The sine theta is opposite over hypotenuse. So it will be opposite is equal 8 over hypotenuse 15. Now what is the cosine theta? Cosine theta is the adjacent over hypotenuse, which is equal 15 over 17. So I have mistake here in the sign because I said it's opposite over hypotenuse, but 15 is not the hypotenuse. So let's erase the 15 and write 17. Now, how about the tangent theta? So the tangent theta, it's be opposite over adjacent. Opposite is 8, adjacent is 15. Now, let's find the cosecant. So the cosecant will be cosecant theta. It's the reciprocal for the sine, 17 over 8. Secant, same thing, is the reciprocal of the cosine, 17 over 15. Cotangent is the reciprocal for the tan, which is 15 over 8. Okay, hope you understand this. Now let's go to the second question. In the second, let's read it together. Use cosine theta equal 2 over 5. Find the exact 5 remaining trigonometric function. We have 6, right? But he gives me the cosine, so I can use this cosine to find the remaining 5 trigonometric. So the first step that we have to do, just to draw any right angle. So let's say I will draw this right angle triangle. This one here, okay, with this one here. I'll just draw any type. So this is the right angle. So of course the opposite for the right angle is this one. So this one will be my hypotenuse. Now define the angle. You are free to use this one as theta or this one theta. It's up to you. Anyone you would like to use, it will not change the answer. So I will use, okay, this one as the theta, which is this one down. Now, regarding this theta, the opposite side here, okay, will be on that side. The adjacent side will be here on the left. So this one is the adjacent. Now, we know that the rule of the cosine, okay, the rule of cosine, which is given 2 over 5, sorry. So this one is the adjacent over hypotenuse. Regarding the theta, the adjacent is 2, hypotenuse is equal 5. So now I need to find the opposite one. So how can I find the opposite side? So I can use the I can use Pythagorean theorem. So Pythagorean is c square equal a square plus b square. So c square, always the hypotenuse, which is 5 square. Adjacent, 2 square plus b square, the opposite. Now let's simplify. 25 equal 4 plus b square minus 4 minus 4. So 21 equal b squared. Now to cancel the square, we have square root for both sides. So b is equal square root of 21. Now we know that this here is equal square root of 21. Now let's find the 5 remaining trigonometric after we know the triangle. So sine theta is equal, opposite is square root of 21 over the hypotenuse, which is equal 5. Tangent theta is equal square opposite over adjacent, 20 square root of 21 over 2. Okay, now let's find the secant theta, which is the reciprocal for the cosine. So secant is the hypotenuse, which is 5 over adjacent, which is 2. Cosecant is equal 5 over square root of 2. I told you we can't have a square root in the denominator, so what should I do to remove it? I have to multiply the numerator with the square root of 22, multiply square root 21 for this one. So to simplify this, so we get the answer 5 square root of 21 over 21. So the square root cancels the square root. Now the last one is the cotangent theta. Cotangent theta, same thing, 2 over square root of 22. So it will be times square root of 21, square root of 21. So it will be the final 2 square root of 21 over 21, because this square cancels the square. So the answer is 21. So I hope you understand this. Now it's your turn to solve these 3 questions, and the answer is in front of you. If you need any help, please let me know. Now let's go to the solving right triangle. Now solving right triangle, as I told you before, we need to memorize this table. So let's say separate the table into 2 things. Okay, the first one here is the 30, 45, 60. Okay, so we need to memorize this 1 over 2, 2 over 2, 3 over 2, but all of these as square root of 3 square root. So same thing for the cosine, as you can see here, and the same thing for the tan. So we have to memorize this table together. Now for the triangles, as we can see here, the triangles, we have special 2 triangles. The first one 30, 60, 90 triangle. The second one is 45, 45, 90 triangle. So as you can see, we have 2 special cases for the triangle. Why we consider this special cases? Because we can know the sides, the other measure of the side, with only knows one side. Means, for example, look to this one. So let's say we have this example. Okay, the example said, let's say we have a triangle 30, 60, 90. We have to we have to memorize every side present what. Okay, so let's say we have this triangle here. Now the triangle, say this is 60, this is 30, and this one is 90. Now for example, let's say the question gave me this side here is equal, for example, 6. So if I ask you, how do I know the length of this side and the length of this side? If you told me that I can use the trigonometric ratio, yes, I will say yes, you can do that. But how we can find them faster? By using the rule. If we know that this is x, this is 2x, this is square root of 3 times x. So we know that if x is given, I can just multiply x with 2 to get what? To get the hypotenuse. And I can also multiply the x with the square root of 3 to find the long side here. Or let's say the side below here. So this side here, I can say, okay, so this side here, which was with the 30, it will be square root of 3 multiplied with 6. And the hypotenuse can be known by 2 multiplied with the 6. So I can know the answer. Same thing happened with the 45, 45 triangle. We also need to memorize these, which is x. Of course, this one is x. And the hypotenuse can be known as square root of 2 times x. So what we can do if we have another triangle similar to this, and we know that this is 50 to 45, this is 45, this is 90, okay? And we know that one of the sides is equal to 3. Okay, of course, because of the rule, if the one side is equal x, so of course the other side will be x. Now, if I tell you this side is equal to 3, of course the other side will equal to 3. So how about the hypotenuse? The hypotenuse is the x multiplied the square root of 3. So that's mean 3 is multiplied with the square root of 2. So this is how we can know the angle. So that's why these triangles are a special case, because if we remember the rules, it's easy to find the answer.